Welcome everyone to the 2020 APEC Groundbreakers virtual tour by APEC OUZ. This year, our event would be the biggest one ever done, with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages. Please remember to register to as many sessions as you can, and all sessions would be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. First things first, I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, a deep dive into service mesh architectures by Arturo's Viveros. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time on the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Arturo.
Okay, thank you. So then I will just, I'll just share my screen. There you go. Yeah, so welcome everyone. Good evening or morning, depending on where you are connecting from. And yeah, today's presentation is a deep dive into service mesh architecture. I think this is a very interesting topic, and I decided to speak about this, or to start speaking about this, because service mesh is a technology that I'm actually using in a couple of projects already in production in one of them, and but I've been looking into it for a couple of years now, doing also some experimentation and comparing several providers. And yeah, I remember just I think it is really interesting to discuss this this technology. Some time ago, maybe 4 or 5 years ago, I think with some colleagues, we were discussing that we were feeling that the technology that was available out there, the tools were not up to speed with or completely up to speed with our requirements for building modern systems, or all the requirements that come with that, and particularly security. And but now, I think nowadays, it's many technologies have taken a leap, and it's in a good state. It's very promising, and this is one of those technologies for me. So I want to explain why, what it is, and why is it relevant for building, for software engineering. So let's just jump right into it, and we can start from the very simple, because it's a complex topic. It's a complex paradigm to explain. But if we go to the very simple, I think it will be easier. So short introduction. What is a mesh? Not a service mesh, but just a mesh. Yeah, like in the we see this in the everyday life all the time. The concept of a mesh. Right? This is a barrier made of connected strands of metal or any other flexible and durable material. And why do we use a mesh so much? Because it's useful, to create enclosures, to protect stuff, to design structures that are durable yet flexible. Right? The most common type of mesh could be the coil wire fabric that we see almost everywhere. It's practically ubiquitous, in every building, every place. So what's the point of having a mesh? For example, in a zoo enclosure, you want to create a safe enclosure, a place where the stuff that you are protecting cannot come out, but you should still be able to look into the inside. You don't want to stonewall the whole thing, and you want flexibility, and you want to keep the ability to morph these structures as you see fit. So yeah, this is a very common concept. It's something that can be very familiar. In engineering, though, the concept of a mesh or of meshing, it's actually a thing. It's something that's very important for engineering, and I like to mention this because then we start to get the notion that this is not just a buzzword or something that some vendor came up with. Oh, let's call this mesh because it sounds cool, and it's not that. It's the meshing is something that's super relevant in engineering, and it refers to the practice of generating predictive models to approximate a domain, basically by dividing this domain into small pieces using polygons, which we will connect with a series of lines and points. So when we use meshing, we call this technique the finite element analysis, and that's how we build these models. Okay, so this plays a critical role in all over engineering in the product development process. So without meshing, without these techniques that now are aided by, I mean, this has been there for lots of years, but now with the advanced computing and stuff and simulation, we're able to really leverage this kind of technique. And without this, for example, the process to build cars, airplanes, power plants, whatever you can think of, wouldn't be as in the state it is right now. So this is really something that helps engineering and helps technology. So how does it translate to software architecture, which is it's a part of engineering as well? So in software architecture, the concept of mesh or meshing would refer mostly to the same, decomposing a big problem into smaller pieces, right? And then weaving them together in a resilient but congruent, cohesive, and transparent fashion. So it's yeah, it's something very familiar. It's something that's very natural to do. It's not this concept it doesn't attempt to like reinvent the wheel or introduce a lot of complexity where there is no need. It's rather the other way around. It's trying to bring into software architecture a very simple concept, but very useful one that's already there in engineering, and that allows us to build more resilient systems and allows us to weave them together transparently without introducing unnecessary overhead or complexity. At least that's the theory of it, right? Then we have the actual implementation, which we will look at in a second. But yeah, once we've done this brief introduction, it's probably a good moment to introduce myself as well before going on. So my name is Arturo Viveros. You have my Twitter handle there, and yeah, I work at Cisco, a Norwegian consulting company. So right now I'm located in Oslo, Norway, where it's a little bit over 8 in the morning, and I am from Mexico originally, and yeah, my expertise, my focus is on software development, cloud infrastructure in the recent years, service integration for a long time, and data engineering, because most of the projects I'm doing, and especially the ones where we are using the service mesh, are very driven by data engineering, or by the need to leverage and govern and democratize data. So yeah, that's me. And let's just go on and now to the concrete topic at hand. So what is a service mesh? We already saw what's a mesh. So what is a service mesh? This is the simplest possible definition that you will find in Gartner, Wikipedia, whatever. So and it is quite simple. A service mesh, it is an infrastructure ledger that enables secure service-to-service communication. And I think the keyword here is infrastructure. And infrastructure in this context, it doesn't refer to a piece of metal like a server or appliance or a firewall. No, it's software, right? A structural software or infrastructural software that we use as a building block to create more software, to create our systems. Okay, so this is, we might also call it cloud native infrastructure if we like that term. But if we look at the cloud operating model, in this case, the service mesh would be much closer to the infrastructure as a service ledger than it is to the other ones. So we'll discuss this more in depth throughout the presentation, but in some places there's the misconception that the service mesh could be more of a platform as a service offering, but it's closer to the infrastructure as a service because it lies in the infrastructure level. So that's very important to keep in mind, and we will go deeper into this. And the rest of this definition, it's really simple. It's also very it's a blanket definition. It doesn't say much. It enables secure service-to-service communication, but how? What kind of security? So the question I would ask myself is, okay, so which challenges does it actually address? That's important to understand, so we can really understand also the technology. So the number one challenge that the service mesh is trying to address is it's called zero-trust networking, and this is again this is an important concept for modern software architecture. This is a concept where a lot of studies and investigation and research papers and engineering articles have been focusing on this paradigm. It's again not something that some vendor came up with just to sell more licenses. This is something that responds to specific needs in the modern software development space, and it is the main challenge that the service mesh is trying to address. So again, very important, because to don't fall into the misconception that service mesh is its main concern is integration, or that's not the case. It's the zero-trust networking. So let's explain this. What's a zero-trust network? So I'm going to show some diagrams. Maybe I go a little fast through them. So this is a typical network with typical systems and services communicating between them. So this is a very simple picture. Like we have service A, service B, service C. Two services belong to system A. The other service belongs to system B, and they have a need to communicate and exchange data. So this is how do we secure this? Normally, in the typical way of building these systems, we have perimeter security in the network, and we have segmentation done with firewalls or something else. And then, but once we are within the trust boundaries, let's say, of our network, between inside this like safe enclosure that we create with the perimeter security, then we are mostly trusting every system there. So we can communicate freely, we can find IP addresses, we can find the hosts, and even more, if we are within the same system, if we are within the boundaries of system A, then those services are trusting each other by default. There's so trust is implicit here in many levels. This is a very simple topology, but if we go a little bit more complex, if we introduce a second network B, this can be within the same organization or elsewhere. This can belong to a different organization. And how do we connect these networks? Typically, we do like a VPN or some kind of tunnel, but we need the services to be able to exchange data as well. So once we've managed to connect the two networks, then we are also like in a trusted space, and there's a lot of implicit trust happening there. But that's not how it commonly is. It's normally much more complex. So here we have a more complex diagram where we are communicating between simple services, but we also have a distributed system, a system that is more complex in nature, that also needs to exchange data with our services from the network A. Yeah, we can stop there for a moment. So if you see this this diagram, then, and we think about security, then as we increase in complexity, the surface for attack is also increasing. It becomes broader. So there's just by taking a quick peek at this kind of diagram, we can see a lot of vectors of attack, a lot of things that could go wrong, a lot of places where our data could be compromised or stolen or tampered with. So it's and it's not an easy problem to fix, especially since we are communicating different networks. Let me go quickly through this animation to show a little bit more complex. Yeah, so what if we have something like this? Now we have 3 networks, and we have at least a couple of very complex distributed systems in each one of them. So if we look at this, let's just look at this picture, and let's imagine that I'm an attacker. I'm a malicious attacker, and I have bad intentions, and I'm skilled in hacking and being able to get into a network. And in this picture, if I'm able, for example, to impersonate service B, if I'm able to get into network A and system A and impersonate service B, from there, I'm able to do basically anything on the 3 networks, because this service is exchanging data with network C and with network B, right? And then, for example, if I'm able to impersonate and gain access to the C network, then I might be able to get hold of a very complex system that has a lot of nodes and a coordinator and so on. So it's that's what I mean by the surface of attack and the threats that can come from doing this kind of communication. But this has become increasingly common in modern architectures, especially in cloud architectures, where we need to connect several systems, several clouds, or hybrid architectures where we have some things on the premises, some things on the cloud. And then we really have part of our pieces of our data and our functionality spread across the board. So we need this connection to happen, but we need to keep it secure. Okay. So as I said, the service impersonation is one possible threat here. Unauthorized access, very obvious. Some others like packet sniffing, data theft, tampering, and yeah, I put the first 2 in bold letters because those are like the main ones. The rest of those, maybe the packet sniffing or the tampering, we can mitigate with encryption and stuff like this. But service impersonation, for example, that's a hard one. And if I'm able to impersonate a service, then I'm probably able to decrypt the data also. So even if I'm using encryption and SSL and certificates and whatever, if I'm able to impersonate, then that will not matter, and I will be able to get data or to modify data in a malicious way. So yeah. So then let's explain. I will explain now with this in mind what is the ZeroTrust networking. Let's think about maybe a stupid example that I always say about this. Imagine that implicit trust. Okay, why do we need to get rid of that? Why do we need zero trust? Let's think of a real life, as I said, maybe dumb example, but you have your house and you do a party and you invite a lot of people, all the people that you kind of trust, like not just your inner family, but co-workers and some friends, but people that you have a certain amount of trust, enough at least to invite them to your place, right? So you have a party with 30, 40 people in your place, and then but you don't fully trust every person there. So within your house you have valuables, right? So you're probably going to lock your own bedroom at least, and within your bedroom, if you have some jewelry or money or whatever, or important papers, then you probably keep those locked also into a cabinet, right? So even within your own place, you have several layers of security, and you are trying to isolate some stuff, hide it from view, make it unavailable to anyone who has gained access to your premises, right? Even if these people are trusted by you. So it's the same with this kind of system, right? You want to establish some kind of trust or communication, but you cannot implicitly trust every service, every network, every user, every asset or resource within these systems to do anything it wants within the trust boundary. So basically, zero trust refers to that, right? This is a term. It's a cybersecurity term, So where you start moving defenses from static perimeter, from the just resolving this at a firewall level, to focus more on the users, the assets, and the resources that are interacting. So you want to have a fine-grained control over who's entitled to do what and where exactly. Right? So the fact that I am within the network, it doesn't give me, it doesn't entitle me to do or to have access or to consume all of the resources that are there, or groups of resources. Right? So the zero trust architecture would use the zero trust principles to plan accordingly, right? To plan our enterprise infrastructure and our workflows according to this concept. So going back again, we have this kind of workflow. So we have some very clear interactions there. So let's say, for example, the service A from system A, network A needs to get some data from coordinator F in network C, and then it needs to communicate with service C in the system B, and then service B will go to another network. So this is a complex workflow. So when we plan for how this workflow is going to work and how security is going to be implemented, we're going to use the zero trust principles to design it, right? And to design our infrastructure, our underlying infrastructure accordingly. So so there is a zero trust. So we start off with a zero trust, and we only enable those resources and assets that we really need to communicate within each other. And this can also be ephemeral, which is also very important. If we entitle a service to communicate with another service, this is not going to be forever. This might be for maybe a limited amount of time, or a numbered amount of interactions, which is something that's hard to do with a firewall, right? When you talk to people that do firewalls, they will tell you, yeah, but I can do all of this with a firewall. Yeah, but imagine if you have a complex cloud architecture, then you're gonna have to be modifying the firewall all the time, and that's not safe, and that's not agile to do. It's not tenable, right? It will not work at that scale. So then you need this kind of architecture and this kind of principles to have a really secure network. And you really want to have a secure network because you don't have to, when you're designing a complex system that exchanges a lot of data. For example, we are the project where I'm working, I cannot mention the customer because it's the public sector in Norway, but you can imagine being the public sector, it's very important that the system is safe and that no data is leaked and that attackers cannot gain access and cannot tamper with the system. Otherwise, we would already be on the newspapers or big data breach happening in Norway, as it has happened before in several other examples. So let's just revisit the definition we saw and make it a little bit more to the point. So a service mesh would be a transparent infrastructural layer that enables zero trust networking between services. So this is more, down to earth, right, than the broad definition that just enabling service-to-service communication. This is the way the service mesh enables service-to-service secure communication, by enabling a zero trust network between services. And I added the word transparent because, as we said, this is underlying infrastructure. So in theory, the service mesh implementation should be transparent to the rest of our systems. This shouldn't be something that will add unnecessary complexity or overhead or too much code. I will explain how this works in a second. So, but that transparent word is important there. So how does it work? This is how it typically works with zero trust networking. I have another diagram here, two networks, network A, network B. I think that's the first one I've shown with 3 different services. So the most common way of doing this with all the service mesh, or most of the service mesh providers, is using a pattern called the sidecar proxy. So each service will have its own sidecar proxy, and the services themselves, they will only be able to communicate through their loopback interface in networking terms. So what does that mean? That the service itself is not able to reach anything on the outside, and no one in the outside is able to reach that service. It's only loopback. So there we have part of the zero trust, right? That the service is completely isolated, but then it has its sidecar, and it's the sidecar that's able to communicate with the exterior, to exchange data, to exchange certificates, to establish a secure channel, right? And the sidecar it's just that, it's just a sidecar. So we can enable, disable it at any time. If it's compromised, we can just smartly remove it or cancel it, but the service remains intact. And we have a control plane, which is transparent infrastructure, as I said, and it's controlling the way these proxies interact within each other. I added also this green box in the top, service scheduler, because when we have a service mesh, it doesn't make sense to enable or to implement this kind of architecture if we are not able to dynamically schedule services, and especially the sidecars. So service scheduler, it can be something like Kubernetes, it can be something like Nomad, it can be something else, but we really need the scheduling capabilities in order to properly implement a service mesh. So without scheduling capabilities, it doesn't make sense, because then we would have to manually or through scripting or something spin up the proxies, and then we completely lose the ability of dynamically doing it and controlling this at scale. So zero trust networking, what are the components or the basic components of this? The control plane, as we just saw, the data plane, which is the sidecar proxies, the place where the data is actually being exchanged. That's the data plane. The control plane would be the technology that we are actually using as a service mesh. So, for example, Istio or Consul or Linkerd, or I'm going to go into the main providers in a few slides. And we have mutual TLS. So this is also mutual TLS. It's not something new. It's something that has been there and has been improving the way we operate with certificates. But the way that these sidecar proxies establish mutual trust is by doing mutual TLS with certificates, but a specific kind of certificates. This is not like the typical certificate that it's all powerful and that will enable you to access a whole network. Here, each and every service and each and every asset resource on these networks, on these systems, will have its own certificate, its own service identity, which is it's like a unique passport, a unique credential that each service or each asset here has, right? And these certificates can normally be, or you should be able to handle them in your control plane with a proper strategy. So it doesn't add overhead. They can be dynamically maintained and dynamically created or rolled out, and so recreated. We have, as I said, the orchestrator or scheduler. This is a very important component of a service mesh architecture, as I already explained. But we also, this, as I said, is the typical, or the normal recipe, right? Like right out of the book. How would you implement service mesh like this? Every provider will work mostly in the same way. But you also have a native integration API, and commonly. Why is that? Because if we go to the next diagram, it's very possible. It's the most probable that you will have you have systems, legacy or not legacy, but systems implemented in other technologies like, I don't know, Java or .NET or whatever, that are they are not managed with Kubernetes or with Nomad, or they are not. Those systems were not developed in this modern patterns, and that's not a problem. That's okay, but we want them to participate in the service mesh. So, for example, in this diagram, we have a couple of services that are controlled by the service scheduler, but we have the sidecar proxies. So we are probably looking at the Kubernetes here in the scroll in the right, and we have our control plane. But we have a big system in the left in a different network, and this system is important for our workflow, and we want the system to be part of the service mesh. So what's the way to do it? It would be very cumbersome to try to spin up sidecar proxies for this internal architecture, which is already complex. And this system has a coordinator, so it has a distributed architecture of its own, right? So what do? We can leverage the native API. And through a very simple API authorization call, we can interact with the control plane. And how do we typically do it so it remains transparent, so we don't have to modify the code in the system, or we don't have to do a lot of implementation there? We can use a service agent. That's the typical way to do it. Deploy a service agent in this network within this boundary, and the service agent can take care of the rest. It can be, for example, if we're using Consul, let's say, it can be a Consul agent, which is very lightweight, and then the agent will take care of stuff. It will redirect the API authorization calls to the control plane and back to the coordinator, and it will answer just a simple yes or no. Like yes, you're authorized to exchange data with service A, or no, you're not authorized, period. That's it. So yeah, that's how it could work. But then it's very important that that our service mesh provider has this native integration API, and that it's properly documented, and that we can see the actual examples, because yeah, it's in enterprise software development, the most common thing is that we're going to run into old systems or systems that are already there, and we want to integrate them with our newly implemented service mesh. If we don't have that ability, then it doesn't really work. It doesn't really fit into our strategy. So some examples of service mesh implementations, at least that the ones that I've been able to work with or test so far. So yeah, the most famous one, the most popular one, and the one who has grown the most is Istio, especially because of the synergy it has with Kubernetes. So that's a very big one. We have Consul from HashiCorp, which is in my personal preference, it's been my favorite so far. I've worked a lot with Consul, and it's like a Swiss Army knife, because you can use it with Kubernetes, but you can also use it outside of Kubernetes with traditional systems, and it's like a central nervous system to your network and your architecture. So it's a nice product, and it's grown a lot as well. You have Linkerd, which is also quite popular in some contexts. This is the one. This I haven't used in actual production projects, but I've done some experimentation, and it's very robust as well. I find it, yeah, not as it's quite developed, but I think it's just a step behind Istio and Consul, but that's a personal opinion. Let's see. I can be wrong. I could be wrong. We have other lightweight options, for example, like Mesh. This is a very nice one. This I found out because we are using a product from this same company, which is called the Traffic, which is an edge router, but they also created Mesh. And yeah, it's a lightweight service mesh. This company is called Continuous. They are very innovative. They create this kind, and they document their software very well. So if you're just looking for a very open source and very small option to do this, mesh could work. Although, for example, if you look at Consul, Consul it looks big, but it's just a single binary in developing Go. So it's very lightweight. It's open source as well. So it doesn't add a lot of overhead to your architecture. You have Kuma, for example, if you look at the Gartner quadrant, and you will see this one, and you have the vendor-specific ones. So if you go into Azure, AWS, Google, they have their own implementations as well. So you have AWS App Mesh, you have Service Fabric Mesh in Azure. You have this one I've used. It's all right. Yeah, what is the thing here is, at least with Consul and Istio that I follow closely, the development is happening at a very fast pace. They are releasing or performing releases like almost every other day. So you get a lot of features all the time. You get a lot of issues resolved very quickly. You're also able to contribute if you want to the projects and interact with those, since it's open source. So with those two, at least, even with the Linker or Mesh, I would say if you use this technology, you can be constantly like on the bleeding edge of the new developments, which can be good because new features and new requirements are always coming. With the vendor options, you have to keep in mind that it's a big vendor, it's a big elephant, so it moves slower. So for example, if you use Service Fabric Mesh, you will have to adapt to what they are offering. And if you want new features and if you want this to change radically, you will have to wait for maybe a long time, or it won't. So it's more difficult to influence this kind of technology than it is to influence maybe Consul, right? Or Istio. So that's the only thing, but the products I think are solid. I haven't tried AWS App Mesh, just read a little of the documentation. And yeah, we have only a few minutes left. So this is very important for me to dispel some myths about the service mesh. So is service mesh a service mess? I've seen people call it like this on Twitter, for example, and I really don't think so. I think that comes from a misconception of what service mesh is for. Service mesh is not a product or a technology that it has been created to do integration and to replace, for example, enterprise service bus, or to replace the SOA architectures. That's completely not the point. And if you are trying to use service mesh for that purpose, then yeah, you will probably end up with a service mess instead. But no, that's not the case, as we just explained. Is service mesh only for microservices? No, not really. And as we also explained, there's native API in most of these providers that will allow you to include different kinds of systems of implementations into a service mesh. Of course, it fits very well with the microservices architecture. That is true, but it's not only for microservices. Is it only for Kubernetes? No, not really. That's also a misconception. If you look at Istio, then yeah, Istio works very closely with Kubernetes, but Istio is not the only option out there, and they don't have a copyright on the service mesh. There's a lot of technology out there that can be used outside of Kubernetes. Although again, it's a very good fit. If you have a Kubernetes implementation, then you probably want to have a service mesh controlling handling your interactions, especially if this is a distributed system that spans different clouds or different networks, as we saw. But yeah, that's I think that those misconceptions are easy to dispel. Some key takeaways from what I just said. I think that the main one is service mesh is an infrastructure pattern. That's very important to keep in mind. It is an infrastructure pattern. So in order to implement service mesh successfully, the first thing that you are going to need is good infrastructure people. That's super important. So you need to get hold of the people that really know, for example, the certificate, the TLS stuff. That's key. You want to get hold of people who are acquainted or that are skilled with network topologies, how to segment a network, how to protect a network, stuff like this. So that's very important. Another part of the misconception of the service mesh is because people think that service mesh is an integration technology or just an integration technology. It's sometimes you begin exploring that technology. I've seen this in a couple of organizations. Okay, we want to explore service mesh. So who's going to do this? Then I will commission these integration developers that they used to work with OSB, Oracle Service Bus, or with something like this. Now you are in charge of implementing service mesh because you should be able to, because you have experience with integration. But then that probably will fail, or they will run into a lot of trouble, because this is not an integration technology. This is an infrastructure technology, and they probably lack the full skill set necessary. So you need to get the infrastructure people to collaborate on this to get a sound, robust implementation. You need to understand how your systems work, and that's a very good thing. So service mesh really forces you to understand the underlying intricacies of your system, how your workflows are supposed to work, what's supposed to happen and what's not, what's the desired state. So you cannot just fast code through this and yeah, let's throw the code and then we'll see afterwards if it works or not. That doesn't work with the or that's not a good pattern, a good idea. It's never a good idea, but especially with service mesh, because then you will end up with a service mesh. And you should never forget that the primary concern is security. So if you want to start exploring service mesh, or you want to bring a service mesh technology into your ecosystem, into your network, into your enterprise software architecture, then your primary motivation should be security. So then you should probably start by speaking with the security people, right? The security officers in the company, with the people that are in charge of this. Because if you implement service mesh, this is going to change the way you look at the security within your service architecture. Okay, so that's very important. And so here, security cannot be an afterthought, as it usually is. It's the first thought that you need to have when doing service mesh. And before answering a couple of questions, yeah, this just a personal, heartfelt recommendation. If you are in the process of forming an opinion on this or any technology, I would encourage you to look into all the content produced by serious practitioners and engineering teams, whether it's papers, blogs, whatever, rather than just going to Twitter and reading the hot takes that you find there, or vendor-driven propaganda. So yeah, if you just go into Twitter and put service mesh, you will find all kinds of crap, or some good things, but some really bad. And it's not advisable to form your opinion of the technology from those. Even some very known or very good or very knowledgeable people in Twitter will sometimes just tweet like shit takes because they are looking for likes and followers. So it's better to go and read the actual stories of how this was implemented and lessons learned and pitfalls and success stories and stuff like this. Then you will get a good idea of how this works and if it's for you or not. I added a couple of references, so this presentation will be available in our blog in Cisco. If you want to look at the demo and the practical stuff of how we implemented this in our project, these blogs talk about that, and they have links to a YouTube video that we did for HashiTalks, and to some other presentations that explain it like step by step, very technical, very deep into the actual implementation. So that's that, and I added also some references that I consider good readings on the topic from diverse providers. So yeah, now I will. I think I don't have any questions on the Q&A in the chat. Let's see. Okay. So no
any question?
So far. Yeah. So yeah, thanks to the people who connected for being in the presentation. I hope it has been interesting for you. This will be recorded, and it's being recorded anyway, and it will be available on demand. So if anyone wants to ask me any question, you have my Twitter handle, and you can reach me there. I will be pleased to discuss anything with you. So yeah, thanks a lot for attending today.
Yep, I guess there's no questions. So thank you for attending this session. So once again, you can share the link later. And of course, you can always provide feedback to Arturo. Thank you,
When,
and enjoy the rest of the conference.
I just saw that my
Thanks.
friend, my good friend Mark is connected. So hi, Mark. Nice to see you. But, yeah.
Okay.
Talk to you later.
Thanks, Arturo, and have a good day.
Yeah, you too. Thank you.
Okay, bye.
Bye.